Welcome to solverfy.
In this problem, you're asked to consider how particle volume affects PV equals nRT, essentially, or essentially how much a gas behaves like an ideal gas. Thing is that with an ideal gas, we assume that a particle has no mass and therefore basically no volume. So this equation just becomes false, and instead we get this nice big new equation. And this section here, V minus NB, is what accounts for particle volume. So what will happen is that the bigger the particle volume, the less actual volume there is within a container. So that is why we see V minus. So the bigger the particle volume, the less it is like an ideal gas. So in your book, it says to refer to table 5.3. This is a typo, and it probably should be table 5.4. I can't show you that, but if you go there, you will actually find the gases it talks about, which are chlorine, hydrogen, and oxygen. So you can examine B, and this will essentially correlate to how big the volume of a particle is. The higher the B, the more it deviates from the ideal gas law. So chlorine will actually, if you look in your book, has the highest value of this constant. Oxygen is in the middle, and hydrogen is the lowest. You can also think about their volumes. Chlorine is by far the biggest particle in this case. So from that, we know that chlorine deviates the most of these three gases from ideal gas behavior. It is followed by oxygen, and last but not least, hydrogen varies the least because it is the smallest molecule. Thanks for coming. Hope this helped you all out a lot.